Alrighty, class.
Yes.
Alright, this is my 7th hour today.
Yes.
Wow, you stink at this. Okay, anyway. I know. Okay, so we're going to be on page 18 and 19 today in our interactive notebook. So for this first one right here, it says describe the growth of this geometric sequence. So what do we say this one was? 1.5. Or what if I wanted it as a fraction? 3 over 2. Thrace over dos, right? All right, so let's take a look at the next one now. So it says one way to describe its growth is to say growing by percentage each time. What is the number that goes in blank for the sequence 16, 24, 36, 54, 81? Be prepared to explain your reasoning. Now, first, what does the word percent mean? Out of 100. Very good. So it's out of 100. It's actually a compound word. Kind of like, slap earbuds out of head because you should not have them in right meow. But you're just trying to ignore me. That's not cool. No, you're not. You got your earplugs in and you're trying to ignore me. Man, bro, it hurts my feelings. It hurts my feelings. It really does. Anyway, so, all right. So now for this one right here. So we said that percent is out of 100. Okay, that is a amazing definition. Percent is out of 100. So we take this. So I'm gonna show you this neat little trick for this right here. So we're gonna figure out the percent. So now whenever I'm doing this, it's gonna be f of n divided by f of n minus 1. Now, f of n means what? Whatever term it is, right? And then f of n minus 1 means the previous term. So it says whatever term I have, and then it's divided by the previous term. Yep, the one before that. Go ahead, sharpen. Go ahead. Do you want the little twisty thing? Little handheld one? You want that one? Okay, a little bit too much. So, all right. So if I'm going to do that, I'm going to use these two numbers right here. So f of n would be what? Someone say 24.
24.
Over. Now, f of n minus 1 is 16 because that's my previous term, right? Why could I not put 16 on top? There is no previous term, my first term, right? So, very good. So, there is no previous term on that one. So, now, 24 over 16. Now, go ahead, handy-dandy calculator, and mathinate that one, please. Yes, mathinate. That is a new word. Go ahead, I am coining that. Go ahead, YouTube. That's copyright right now. Okay? Every time someone uses mathinate, that's, yeah. I get money. What do we get? 3 over 2 or 1.5, which is the same thing, right? Now, the word percent, so watch this, watch carefully. I have that as a fraction. So, the word percent means out of 100. So, if it means out of 100, that means what number goes on the bottom? 100. So, to make this right, I need to multiply top and bottom by 100. Because it's supposed to be out of 100, right? So, 1.5 times 100. And what do we get? Go ahead, say it. 150 over 100. 150 over 100. Now, if it's out of 100 now, that is now my percent, isn't it? So my percent is what? So this is how we turn a decimal into a percent. So it is going to be 150% of the previous one. That's what that means. Make sense or no? Anyone? Questions? Complaints? Concerns? Yes. That these two right here? Okay, I took these two, which is my term, and this means my previous term. I could have used any of these. I could have used any of them. If I used 54, I would have divided by 36 because that's my previous term, right? So I could have used any of them. All of them are going to be the same. All of them is going to give me 1.5 because that's the factor I get over here. That's where I get those from. I could have used any of them, but as long as I use just the previous term. Okay? All right, good. So I have 150% on that one. Now, let's take a look at this second problem right here. And on the second problem, I need to add some columns because they didn't give me enough. They didn't give me enough columns on this. So let's go ahead and make 2 more columns. There we go. There's A and there's B. So it says the table shows 2 animal populations growing over time. Okay, now let's take a look. So in the initial year 0, I have 23,000, and then it goes up to 29,000. How much is the growth? 6,000, right? So I'm going to say over here, plus 6,000. Now how about going from this one to this one? 6,000? You guys agree?
Yeah.
Yes. All right, so let's see, plus 6,000. All right, let's keep going. What about the next two? Plus 6,000 again. And then my last ones. $6,000? Okay. So I get plus 6,000 for that one also. All right, let's go down to 1. I'm not done yet, so I'm just going to come back to the other part. It says the sequences represented for population A and population B, arithmetic or geometric, explain how you know. Is this one arithmetic? Class?
Yes.
What is arithmetic? Same number. Adding, subtracting, same number. Class?
Yes.
That means everyone. Yes, you. I see you there. All right. What is geometric? Very good. Multiplying and dividing by the same number. So, let's take a look. Is this arithmetic or geometric? So, if it's arithmetic, I'm going to say that population A is arithmetic. I don't know, I could never spell it. R-I-T-H-M-E-T-I-C. Arithmetic. Okay, explain how I know. Because I add 6,000. Okay. Now, let's take a look at population B. And I got to figure this one out right now. All right, so let's see. Now, we're going to do the rates over here. So, from my first one to my second one for population B, what is it doing? 625, right? How do we figure that one out? Yep. You take the second one, and then you subtract the first one. So take the second one, and then you subtract the first one. Okay, so now, what about second to first? How about these two? 750? Yeah, 750, so plus. All right, what about the next two?
900 and 1,080.
This is plus how much? 900. Now, am I losing anyone on this? Anyone have any questions on where and why?
It's just subtracting the number with the.
Yeah, from the previous to see how much is going up. Okay, and my last one's going to be 1080, right? All right, so is this, so let's try this again. Class,
Yes.
is this arithmetic?
No.
No, it is not arithmetic, is it? So since it's not arithmetic, that means it's probably going to be geometric because it didn't give me the option for neither, right? So let's figure out the rate now. We're going to do the rates for this one. So I'm going to do another column over here for B. Okay, so we know arithmetic did not work out. So this is also B. So now to figure out the rate, we're going to do the same thing as what we did over here. So if I'm doing the same thing that I did right here, that means what am I going to do in my calculator? Write me out. 3,750 over. Very good. Everyone's doing that right now, right? Right, meow. Meow. You're picking up the calculator, meow. And you're going to the scratch pad. And you're going to take 3,750 and divide it by. Yep, you're doing that right, meow. Give me a fraction. So this is 6 over 5. I don't like the decimals. I really don't. I like fractions. Fractions are your friends, not food. Okay. What about the next two?
Same thing.
So we get 6 over 5 again. 6 over 5. What about the next two? 6 over 5. And my last two? All right, so if all of them is now going to be 6 over 5, what would I say this is now? Geometric. It is geometric, and we'd say what? Multiply by 6 over 5. Está muy fácil. See. All right, super easy. Write an equation to define population A. So if this is an equation to define population A, is this regressive? Do I need my previous one?
Yes.
Say no.
No.
I do not need the previous one, do I? I do not need the previous one, so let's go ahead and state it as is. So this would be A of n is going to be equal to, so this one is not going to require the previous one. So what am I starting off with? No.
Are you busy?
Yeah, I'm kind of teaching a class.
Oh, okay.
So we have this. Now, I'm going to start with 23,000. Now, repeated addition. If it's adding 6,000, adding 6,000, adding 6,000, repeated addition is the same as what? Very good, multiplication. So now, how am I going to show this as multiplication? Am I adding or subtracting here? Adding, so let's add. How much are we adding? And how am I going to show that this is going to be the repeated addition? Times n. Very good. So times n. That's where it is right there. Where's that thing still over there? All right, there we go. So now, this is not going to be the previous term. So we're going to have to get all the terms out of this. The first term is not going to be given to me. So let's define n. N's going to have to be what? If I plug in 1, what do I get? I get 29,000. That's not what I want, do I? It would have to be 0. Very good. So when I'm defining it like this, I'm going to have to actually get every single term, because if you notice, I'm not stating the first term. I'm not stating the first term here. I need to use this to give me every term in this sequence. So if n is going to be greater than or equal to 0, so now 0 times 6,000 is 0, right? Plus 23,000, there he is, 23,000. So that's my first term. And then 2, that would give me 29. Okay, I'm sorry, it would be a 1, so it'd be 29, and then it would be 2, which would be 35,000, and then 3, which would be 41,000, right? Makes sense. Questions? Too easy? We have a test on this on Friday.
This Friday.
Yep.
This Friday?
Yes, this Friday.
How do you know correctly which one is arithmetic and which one's...
Oh, thank you, thank you. Now what?
How do you know exactly which one's arithmetic and which one's geometry?
Okay, so now that is a very good question. If you notice, this one appears adding the same number every time, right? So therefore, that is arithmetic, right? And the next one, is it adding the same number every time? No, it's a different number every time, right? So if it's a different number every time, I use my little trick that I showed you right here to figure out what that value would be. So every single time, which I did this right here, is it multiplied by the same value every time? If it's multiplied by the same value every time, that means that is going to be a geometric. So that's the basic two steps on this. So eliminate arithmetic first. Okay, so this one worked, arithmetic, this one did not. So then check geometric. Okay? Make sense? Okay. So now the next one, 3. Write an equation to find population of B. So now, if it is going to be repeated multiplication is the same as what? Exponent. So it's going to be an exponent now, right? B of n is equal to, what am I starting off with? Say it.
3,100.
Right? Now it's going to be times what? 6 over 5. Anything else?
Power of it.
Power of the n power. Sound like a commercial. N power. There we go. N power. Now we have to define this, because we have to define it for all the values to get every term in this sequence. So let's see. So n is going to be greater than or equal to, is it 1 or 0?
0.
It is actually 0. Let me show you why. Anything to the 0 power is 1 times 3125. This is 3125. So that is my first number in this sequence right here, right? That's the first number there. So, and after I do 1, which is right here, right? It's supposed to be here, 3750. So this times 6/5 one time is going to give me 3750. So notice how it's going up? Say yes. Okay, good. So, does population B ever overtake population A? This is a lot to overtake, right? What's that, 47,000? And over here it's like just down to 6,000. Is it going to overtake it? Think about it. It's got a pretty good head start. This one's going up 6,000 every time, right? This one goes up an amount that's increasing every time. At a certain point, this is going to be more than 6,000. This rate is going to be more than 6,000, so it's eventually going to catch this. Now, let's see how it works out that it is going to catch it. So I've set this up in your the calculator for you. so you guys can see this. So if you notice, this is my function in blue. That's my first value, my arithmetic. And then my function in red is my second one, my geometric. If you notice, the geometric is going up slowly here, right? But once it gets to some number over here, it starts going up super fast. And then it does, the red line does overtake the blue line. So it does make it faster than this at a certain point, and my point is going to be what? It's going to be 21.25, right? So how many full years is it going to take? 22. Because it's more than 21, but it's less than 22. So you have to call it 22. It's going to take 22 years for this to actually happen.
22.
22 years. Why? Yes. Yeah. So it's going to take 22 years for this to happen. So let's go ahead and take a look at my problem again. It says, does population B ever overtake population A? And, there we go. So we said yes, right? When is it? So population B overtakes population A in 22 years. Now, what does that actually mean? So in 22 years, let's go back to the problem. What year is that actually going to be? Do we have a starting year?
It's gonna be 2000. Oh yeah.
We do, don't we? Yes, it is. So we have a starting year. Everyone look at it. Where's the starting year? 1990, right? So from 1990, I need to add 22. So it's going to be when? In year 2012. It's bad if you're trying to sleep right here in the front row. Right in front of me, too. That's bad. Am I that boring? Oh, man. I'm sorry. All right. There's that one. Now, let's take a look at the back. So, looking at the back, it says define sequence W so that W of n is the number of white squares in step n. Define sequence B so that B of n is the number of black squares in step n. All right. So let's see. First, let's figure out. Sequences W and B, arithmetic, geometric, neither. How do we know? First, I'm going to actually list out my numbers. So the white squares, how many white squares in the first one? 10? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many white squares are in the second one? How many white squares in the third one? 18. Okay, so now let's do the black side. How many black squares are in the first one?
2.
2. How many black squares in the second one? How many black squares in the third one? All right, so now let's take a look at what the pattern is. So for the white, what am I doing? Add 4, right? What about the black? Times 3. What's 6 times 3? Times 2. What's 2 times 2? So what do I say this one is? Neither. Right? Now, I'm going to show you guys the pattern on this, so hopefully it's going to help. So this is a square, which or a rectangle, which is 1 by 2 in the black. This is a 2 by 3. This is a 3 by 4. And the next one's going to be 4 by 5, right? Which would give me how much? 20. So the one after that would be a what? A 5 by 6, which is 30. There we go. So I've explained how it is. So this is a pattern. There is a pattern to this.
It's just complicated.
Yes, it is complicated, right? All right. So now, so the white one is what? Arithmetic. And the black one? Neither. All right, so we're going to write an equation. So this one is not recursive. So that means it does not require the previous term. So for the white one, I'm going to write an equation for this. So let's see. How would I start the white one? W of n. Very good. W of n is equal to? Am I adding every time? Say yes.
Yes.
If I'm adding every time, if I'm adding over and over and over again, repeated addition is the same as multiplication. Plus 4n. Very good. So plus 4n. And now define the n's. N is greater than or equal to 1.
0.
Is it 0 or 1? It is going to be 0. Because 4 times 0 is 0. And 10 is my first number, right?
It's 14.
Yes. Because if I plug in 1, it would be 14. So that's important there. What about, let's take a look at this next one. So B. So B of n is, okay, it's not going to have a pattern like that, right? Nope, it's not going to have a pattern. So we're really not going to get that because it's not going to be a geometric or a arithmetic. So it's not going to work out. Okay, so I'm just going to go with that one. Say, all right, I know that's neither, so it's not working. So there is going to be a pattern for it, but it's not going to be geometric or arithmetic. All right, blank. So is the number of black squares ever larger than the number of white squares? All right, so now let's see. How many do we have here? 1, 2, 3, 4, 5. We have 5 there. 1, 2, 3. So after 3, is the black squares more? No. Okay, so what would be the fourth one? 22. Is the fourth one, is that there? Nope. Nope, black one is not more than that. So what's the next one here? 26. So the fifth terms, is the black one more than the white ones now? Is 30 more than 26? Yes, so we would say yes. When? It is in the fifth term. All right. Does that make sense? Questions, concerns, complaints? No, we good? All right, so now, this is what we are doing since I promised you guys a test this week. So that means whenever we do a test, what do we also do? Turn in the notebooks, right? So damn notebooks need to be in. So make sure you're keeping up with this. So you guys got about 10 minutes left of class. Work on 18. And don't forget, like, share, and subscribe. Hit that notification button.